Hello dear CMA aspirants from South India. As you all already know, Akash Agarwal Classes has launched for you all 100% English lectures in English for CMA Foundation students giving their examination in December 2025 and onwards. So here I am going to tell you how do you enroll in the batch. You just have to join our WhatsApp community which is given in the link. Fill up the Google form again given in the link and to download our mobile application Akash Agarwal Classes to access the notes. You all know the lectures which we are going to conduct will be 100% covered. There would be no subject which we are not taking care of. So we are going to take care of each and every subject, each and every concept. We are going to take MCQs for you. We are going to provide test papers. We are going to take live mentee sessions as well. Lectures which we are going to take for you all are 100% recorded lectures and not dubbed lectures. And you all know we have exclusive team ready for you all to teach you for your CMA Foundation December 2025 attempt for subject wise as well. And we are uploading the lectures on a weekly basis. All the important links which will be useful to you all are uploaded in the description box. Since we have many students who have cleared CMA examination at all the levels from Akash Agarwal Classes, and to reciprocate the love which we have received from South Indian students, we are here for you all taking lectures 100% in English, so that we can clear your CMA Foundation December 25 attempt together. So keep studying, do watch all the lectures till the end, and do show some love by liking the video, subscribing to the channel, and putting up a word in the comment box. Keep studying. Bye-bye.
Hello my dear students. So in today's lecture, as you all know, this is going to be your dispersions part. In last lecture, we have studied all about your quartile deviations and range. Let us first recap before going to the new topic today. The new topic is going to be mean deviation. So before starting with the mean deviation, what we are going to do is we are going to discuss and we are going to revise what we have studied in the last part. So as we started your, just give me a minute. As we started your mean deviation, range and quartile deviation in the previous lectures. Before that we studied there were two types of deviations, right? And the first type was absolute dispersion, absolute dispersion, and the other one was relative dispersion. Yes, in absolute dispersion we were going to study about the range and the coefficient of the range. Simultaneously, similarly, we were going to study quartile deviation and coefficient of quartile deviation. Later on, we have already studied what? We have already studied range, coefficient of range, quartile, and coefficient of quartile deviations. So if you remember the formula of range was largest observation minus the smallest observation. And your coefficient of range was largest observation minus smallest observation upon largest observation plus smallest observation into 100. So the range was something like this, and the coefficient of range. Then we studied what? We studied mean deviation, and the mean deviation was your we studied quartile deviation, and quartile deviation was nothing but we have to find two quartiles. The one was Q3 and the other one is going to be Q1. So what are we going to do over there? We are basically going to subtract Q3 minus Q1, and then that is going to be our quartile deviation. In quartile deviation, there were two types. One was interquartile and the other was semiquartile. For interquartile, the only formula was Q3 minus Q1. And for semiquartile, the formula was Q3 minus Q1 upon 2. For coefficient of quartile deviation, the formula was Q3 minus Q1 upon Q3 plus Q1 into 100. So this is all we studied about the measures of dispersion. Two types of measure, the absolute and the relative. Total 4 parts are done. And now today we are going to study mean deviation. Okay, so just like your quartile and your range, we are going to study mean deviation. Both the parts of mean deviation, one is going to be your absolute and the other is going to be your relative. So what is mean deviation? First you want to understand that. For mean deviation, like for quartiles, it was necessary for us to know about how to find the Q3, that is quartiles, which we have studied in central tendencies part. So similarly, now for mean deviation, it is important for us to study about what? About the mean. the mean, the median, and the mode, because now we are going to find mean deviation from mean, from median, and from mode. So it is going to basically you have to know, you have to understand about what, about the mean, about the median, and about the mode. Then and then only we are going to understand how to solve mean deviation from mean, median, and mode. So everybody is going to start with me. Uh, just give a heading, that is mean deviation. Just give me a minute. So the heading is going to be mean deviation. Heading is going to be mean deviation. Mean deviation. Okay, hello, 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 hello. Hopefully I'm audible. Yeah, mean deviation. The first part for mean deviation is going to be individual series. That is your raw data. Raw data. Okay. So likewise, same like your central tendencies, same like your range, same like your quartile deviation. There are going to be three types of series: raw data, group data, and group data. So you have to keep one thing in mind. In mean deviation, we are going to study three parts. One is going to be from your mean. So mean deviation can be found from means. So there are three types of mean, as you all know. One is your mean, the other is your median, and the third is your mode. So first is your mean, second is median, and third one is your mode. Mean, median, and mode. Okay, so as everyone knows what raw data is, how do we find mean, how do we find mode, everything, everybody's has an idea about that. Hopefully I'm assuming that you have studied central tendency before starting dispersion. Okay, so you know how to find the mean. The formula for mean is x bar is equals to summation of x upon n. For median, n plus 1 upon 2 observation, and for mode, most frequently occurring item, right? So these are the formulas. So for here in mean deviation, the formula is going to be, you have to understand the formula, summation of x minus x bar upon n. For the median, your formula is summation of x minus median upon n. For mode, your formula is going to be x summation of x minus mode upon n. There's no need to worry. Yes, the formula are different and it is something new for you all. So don't worry, I'll be explaining everything. So yeah, don't worry about the thing. So first, let's try and understand. Mean deviation can be found from mean. We need mean to find mean deviation, right? There are three types of mean. One is mean, the other is median, and third is mode. So we will go to find mean deviation from mean, mean deviation from median, and mean deviation from mode. So this is, in mathematical terms, we say it to be mean deviation about mean, mean deviation about median, mean deviation about mode. Okay. So now how to find x minus x bar? Now every one of us know that x minus x bar is what? Sum of deviations, right? So this sum of deviations is what we have already studied in the central tendency part and in the statistical description part, that the summation of x minus x bar, that is sum of deviation from mean, is always 0. So sir, when we are going to count, when we are going to calculate sum of deviations, that is x minus x bar, it is going to be 0. So 0 upon anything, it is going to be 0 only. So sir, what is the reason? No. When we find summation of x minus x bar, there is difference between this thing and this thing I have written over here. Because the x minus x bar is what? There is no mod sign over here. Over here, there is mod sign. What does the mod do is, everyone is aware about that thing. The mod does is, it just removes what? Your negative sign. And once the negative sign is removed, the answer is not going to be 0. Your answer is not going to be 0. We are going to solve many examples out of it, so you're going to get an idea. So for now, you just have to do is what? You have to just keep going with me. Just note down the things, everything I'm giving you, and then we'll have some discussion over it. We'll be solving many examples, so that after that you'll be getting an idea. For now, yes, it is going to be something new for you. So just be patient, have some wait, just note it down. We'll come up with. The next is going to be ungrouped data. Ungrouped data. There is ungroup series. In ungroup series, again, we are going to study for mean, median, and mode. Okay. So for your mean, the formula is going to be summation of x minus x bar upon n. For median, summation of x minus median upon n. Summation of x minus mode upon n. So this is a formula for ungrouped data. And now over here you can see that there is no much difference. There is no much difference between your raw data and ungrouped data. The only difference is summation of f over here. And now, as we all know now, I'm hoping that you are everybody is aware about the summation of f. Summation of f is what? The frequency, the number of observations. I've already tried to relate it. In raw data, there is n. The number of observations are counted and denoted by n. But in case of your group series and ungroup series, it is denoted by what? Summation of f. So summation of f now becomes what? Your new n. Everybody is aware about the same thing. So your ungrouped data's formula is summation of x minus x bar upon n in case of mean. Summation of summation of f, x minus median upon n in case of median. Summation of f, x minus mode upon n in case of mode, right? So now let's go to the group data. For grouped data, no, for group data there's nothing new. For group data there's going to be no different formula. Now let's jump to the coefficient directly. Coefficient. Now students will start spamming the chat. So isn't there any formula for grouped data of mean or mean deviation or something like that? No. If I'm not writing something in your book, if I'm not telling you to note down, you have to just trust the process, trust AC, trust me. I'm not going to skip any of your part. So if I'm skipping something, or if I'm not telling you to note it down, it is not going to help you, or it is not going to be asked in your exams, or it is not none of your use. So you have to just trust me. So don't spam in the chats, or where's the formula, where's the formula. Okay, there's no formula for that. Coefficient of mean deviation. Now we are into what? This was what? The mean deviation. This was absolute measure. This was what? Absolute measure. Now we are studying what? Relative measure. We are studying relative measure. Okay, so the coefficient. Let's come to the coefficient of mean deviation. Now let me tell you one thing. For finding coefficient of mean deviation, you need mean deviation. So what are you telling? Yes. If the question is asking you find coefficient of mean deviation, it is mandatory, it is must that you need mean deviation. So for finding relative, finding relative dispersion, you need what? You are going to need your mean deviation, the absolute dispersion. You have to keep that thing in mind. Okay. So here your formula for mean coefficient of mean deviation is going to be, as I said, we are going to need what? Mean deviation from mean. I'm writing something in the subscript form. That means over here, you're in your base form. This is what? Mean deviation that is found from mean. Mean deviation found from means what? Summation of x minus x bar upon n. So when you find out this becomes what? Mean deviation about mean. Mean deviation about mean. Okay. So mean deviation about mean into 100 upon x bar. This is going to be mean deviation about mean into 100 upon x bar. Okay. So this is your first formula for mean deviation about mean. The second formula is mean deviation about median into 100 upon median. Mean deviation about median into 100 upon median. Okay, so the next one is going to be from mode, mean deviation about mode. So I can write mode in the base, or I can write z also, because you all know that z is nothing but mode upon z. So this is going to be your coefficient of mean deviations formula. Okay. So we have seen what? We have seen mean deviation from mean, from median, from mode for raw data. What was the formula? Everybody is going to say out, say out loud with me. It is going to be for individual data, for raw data, what is going to be the mean deviation? The mean deviations formula is going to be summation of x minus x bar upon n. For median, the formula is going to be summation of x minus median upon median, right? Sorry, upon n. And the formula for mode is going to be summation of x minus mode upon n. So this is going to be your formula for individual series. What is going to be your formula for ungroup series? It is going to be summation of f x minus x bar upon n, summation of f x minus median upon n, summation of f x minus mode upon n. This is going to be for your ungroup series. Later on, we come to the relative measure. It is coefficient of mean deviation. The formula is going to be mean deviation about mean into 100 upon mean. Mean deviation about median into 100 upon median. Mean deviation about mode into 100 upon mode. So this is going to be your formula. This is going to be what? Your formulas. Now don't worry, as I said, we are going to solve many questions. We are going to solve examples for all the mean deviation part and the coefficient as well. So don't worry about that. Hopefully the concept that I have given over here or explained over here is clear to you all. Now let's go to the mean deviation. Let's see if I get some mean deviation point. Okay, so for the mean deviation, okay, so here is one question for us. Find mean deviation about mean. Okay, so this is a very important point that I have to keep in mind. The question always states, the question always specifies about what are you going to find. The question is asking over here, find mean deviation about mean. So you have to find mean deviation from what? From mean. For the following numbers, 50, 80, 100, 100, 120 and 90. So what kind of data is this? The data is your raw data. Okay, so example one over here, everybody is going to write with me. So there's going to be an x, 50, 80, 100, 100, 20, 120 and 90. So this is going to be your x. We want mean deviation about mean. So if you remember the mean deviations formula about mean, it was summation of x minus x bar upon n. Right? This was the formula. So what do we need here now? After looking into the formula, what do you need here? We need x minus x bar. So we need x minus x bar. For that, we need x bar. And how do we calculate x bar? We are going to calculate x bar by finding out the mean. It is going to be 50 plus 80 plus 100 plus 100 plus 120 plus 90. The summation of x is 540. The summation of x is 540. And how many numbers do we see over here? There are 6 numbers. So I'll take this a bit. Here your x bar is equals to summation of x upon n, that is 540 upon 6. It is going to be 90. So your x minus x bar is 90. Okay, so now what are we going to do over here? We are going to 50 minus 90. is going to be 40, right? Minus 40. For now, just try and understand what am I writing over here. Now, this is going to be 80 minus 90. This is going to be minus 10. 100 minus 90, it is going to be 10. Again 100 minus 90, it is going to be 10. 120 minus 90, it is going to be 30. 90 minus 90, it is going to be 0. So if you see now over here, this is minus 50 and this is plus 50. So when we add this, I'm going to get summation of x minus x bar to be 0. But when I don't use the signs given here, that is mod. So as I've already proved before this, that the summation of x minus x bar is always 0. But for calculation of mean deviation, I need mod of x minus x bar. So what is this mod going to give you? The mod is going to ignore the negative signs over here. So when the mod ignores the negative signs over here, this is going to be summation of mod x minus x bar, and this is going to give you 40 plus 30 plus 30, 100. So your mod summation of x minus x bar becomes what? 100. And now your formula will be summation of x minus x bar, that is 100 upon 6. It becomes what? It becomes into 100, right? No, it becomes 16.66666, which can be written as 16.67. So 16.67 is what? 16.67 is your mean deviation about mean. It is mean deviation about mean. And now you see there's an option number A over here. What are we going to do? The question is not asking us to find the mean deviation, coefficient of mean deviation. The question asked us mean deviation about mean. We have already given the answer. Now let's find out mean deviation, coefficient of mean deviation about mean as well. In the same question, we are going to find what? Coefficient as well for our practice. So we are going to find out coefficient of mean deviation about mean. And what is the formula over here? The formula, if you remember, it was mean deviation about mean into 100 upon mean. So mean deviation is 16.67 upon your mean was 90. So 16.67 divided by 90 into 100, it is going to be 18.51, yeah, 5185. So we'll write 52%. So your mean deviation, coefficient of mean deviation is going to be what? 18.52. Your mean deviation, coefficient of mean deviation is going to be what? 18.52. Okay. So what about the percentage? If your question, if your option is specifying, option is using the sign of percentage, then only then you are going to use it. Okay. If there's an option with percentage, then only. Mostly in your answers, the percentage sign is not given, only the values are given, like only 18.52 is going to give. So I just remove the percentage sign. So yes, hopefully the mean deviation about mean part is clear to you all. Now we'll solve one more question, which is going to be mean deviation about median. So you'll all will get an idea how to solve. Now in first example we solved a question for mean deviation which is found out from the mean, Now we are going to solve a question which is going to give you about median. So what is the data for median? You all know that the data is supposed to be arranged in ascending order first. So what is going to be your option over here? Let's solve example number 2. Everybody is going to solve with me. So example number 2 is going to be an x over here, x minus median over here now, right? So let's see x. The smallest observation I can see over here is 52,000. And then I can see is 56,000. And then I can see 68,000, 70,000, 75,000, 82,000, 80,000, and 82,000. So 6 observations. Okay, 3 and 3. Just let me see. 52, 56, 68, 70, 75, 82. 52, 56, 68. There is no 70,000. Or what? Okay, there is 70,000 observation, but it is not given in the question. So yes, your question is half printed over here. We are going to add 70,000 also. Okay, 70,000, 75,000, 80,000, 80,000. Okay, so there are how many observations now? There are total 7 observations I can see over here. So now I have to find what? I have to find median. I have to find what? Median. So what is the median? We know the center one. The center observation. The central observation is your median. So what is going to be the median? 3 over here, 3 over here. So median is going to be 70,000, right? Median is 70,000. Now 52,000 minus 70,000. 52,000 minus 70,000 becomes minus 18,000. But we have a sign, mod sign over here. Therefore, it will become only 18,000 and not minus 18,000. Negative 18,000. 56,000 minus again 70,000. So sorry. 56 minus 70,000. It is 14,000. This is 2,000. This is 0. This is 5,000. This is 10,000. This is 12,000. And your summation of x minus median is 18,000 plus 14,000 plus 2,000 plus 5,000 plus 10,000 plus 12,000. 61,000. It is what? 61,000. So now my formula for mean deviation about median is summation of x minus median upon n, and it is 61,000 divided by 7. So 61,000 divided by 7 becomes, okay, sorry. I don't need mean over here. Mean deviation about median, right? The question is asking me what? Find the mean deviation about median and also the corresponding coefficient. Okay, so it is right. 8,714.285 is your mean deviation about median. It is mean deviation about your median. Now I am going to find what? Coefficient, that is relative measure of mean deviation about median. The formula is mean deviation about median into 100 upon median, right? So 8,714.28 into 100 divided by 70,000 into 100 divided by 70,000. It is going to be what? 12.448. So I can write 12.45%. So the mean deviation is 8,714 and the coefficient is 12.45. Okay? Give me a minute. Okay, so let's get to the next question. We can see over here the mean coefficient of mean deviation they have found, and which we have calculated is same, and also the mean deviation, that is 8,714. So both of them are right. Compute the mean deviation about arithmetic mean from the data. So there's an x given, there's an f given. Which kind of data is this? This is ungrouped data. This is what? Ungrouped data. There is x given and there is f given. We have to find what? We have to find mean deviation about it. Find mean deviation from it. Can you easily find it? Yes, we can easily find it. There's not a big deal over here, because okay, what I'll do is I'll solve one question for you all, because there was 100% there is going to be some kind of confusion that you all are going to create. So I'll solve this. There's going to be a column of x. It is going to be 1 3 5 7. 1 3 5 7. There is going to be a column of f 5 8 9 2. Five, 8, 9, 2. There is now if you remember the formula for mean deviation about mean, the formula was summation of f into mod x minus x bar upon n, right? So again I need x minus x bar. For that I need x. Everything is very true. I need n. I need summation of x. Everything I'm going to need. So this is going to be 5 plus 3 10 16. This is going to be what? 16. Okay, and for this I'll find summation of fx. So 5 ones are 5 over here. Let's keep it on the calculator. Everything 5 into 1 equal to 5. 8 into 3 equal to 24. 9 into 5 equal to 45. 7 into 2 equal to 14, and then gt. So my summation of fx will become 88. Calculating everything on the calculator will give me gt. That's the reason I'm calculating everything on the calculator itself. I guess 44, 45, 14. It's 97. I've missed 5, I guess. Yeah, 97. Let me check once. 5, 24, 45, 14. It is 88. 5, 24, 45, 14. It is 88, not 97. The solution given here is wrong. 5892, right? It is 24. So how do we find mean? Mean becomes 88 upon 24. It's become 3.666. So 3.666 is what is your mean over here, right? So now I'm going to find x into x bar. X bar over here is 3.66. 3.8 they have calculated, which is wrong because the total is not 97 over here. Okay, now once I get the total, once I get the mean, what am I going to do is I'm going to find x minus x bar. I'm going to find what? X minus x bar. Okay, so for finding x minus x bar, see over here what are we going to do in calculation for x minus x bar? Calculation for x minus x bar, x minus x bar, right? So the x bar is 3.66. So 3.66 minus 1 is going to be 2.66. Minus 3 is going to be 0.66. 5 it is going to be again 5 minus 3.66. Going to give you 1.34. 7 minus 3.66 is going to give you 3.34. This is going to be what? X minus x bar. But if you remember our formula, summation of f into x minus x bar. So now I'll be multiplying f and x. This is going to be x minus x bar. 2.66 into 5, 13.3. 8 into 0.66, 5.28. 9 into 1.34, 12.06. 2 into 3.34, 6.68. And now I need summation of these all. 13.3 plus 5.28 plus 12.06, 6.68, 37.32. 37.32 divided by n. Divided by 24, 37.32 divided by 24. It is 15.55. So the mean deviation about mean is what? Mean deviation about mean is 15.55. Okay. So the calculation we have done over here is right, and over here there is some error, I hope, supposedly, because everything total over here for everything is wrong. This is not 25, this is 24. If you add 5 plus 8 plus 2 plus 9 is 24, and not, this is also not 97, this is 88. If I add it twice, 5, 24, 45, 14, it is 88. This is 88, this is 24. That's the reason the answer given over here and our answer is not going to match. Our answer is 15.55. So the mean deviation is 15.55. Mean deviation is 15.55. Just let me check once more. 37.32 divided by 24. 1.55, sorry. I saw the wrong point. 1.5555. So this is your mean deviation. What is coefficient of mean deviation? Coefficient of mean deviation is 1.555 into 100 divided by your mean. Mean was what? Mean was 3.66 into 100 divided by 3.66. 42.409. This is your coefficient. The coefficient also won't match. See, 44. There's a reason there is a difference of 1 or 2 numbers, just because the total taken over there is wrong, and the calculation therefore is done wrong. So this is how we solve. This is how we solve a question of mean deviation, that is from what? That is from ungrouped data. So hopefully the question we have done over here is clear to you all. Yes. So here we complete our mean deviation part. Now let's go to standard deviation. Everybody is going to give an heading for standard deviation now. Standard deviation. So what is standard deviation? It is something new for you all. You have to keep an eye on it. You have to listen properly. Don't leave the lecture from over here. If you have time, you have to sit down and keep a proper eye on it, because standard deviation is something new for you all. So standard deviation can be presented by S or something like this. So this sign is for standard deviation. Many a times in your paper, it would be said to be S, or the sign will be given. You have to understand this is going to be your standard deviation sign. So standard deviation is under root summation of x minus x bars square upon n. So this is your standard deviations formula. Your standard deviations formula is what? Under root summation of x minus x bar square upon n. if you see this, the formula is looking similar but not same. Summation of x minus x bar upon n, when it was in mod, it was formula for what? Mean deviation. But now there is no mod over here. There is no mod over here. We have to find what? We have to find its square. We have to find it what? Square. So x minus x bars square upon n. X minus x bars square upon n is going to be a standard deviations formula. So this formula is very, very, very important. You have to keep this formula in your mind. Standard deviation, if I take standard deviations square, if I take standard deviations square, it is going to be variance. It is going to give me variance. Yes. So standard deviations square is what? Variance. Variance is standard deviation square. There is no formula for standard variance. There is only formula for standard deviation. If question is asking you variance, what would you have to do first? You will have to find standard deviation and then take square of the standard deviation. So you get variance. Okay. And these were what? These were absolute measure. Now the relative measure, that is coefficient of variance. Coefficient of variance is standard deviation upon x bar into 100. So these three formulas are very, 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 very important. So please keep these formulas in your mind. There is going to be a 100% question, 100 not 105% question related to standard deviation in your papers. So this is very, very, very important. Standard deviation. Standard deviations formula is what? Under root summation of x minus x bar square upon n. When we take standard deviation square, I get variance, and the coefficient of variance is what? Standard deviation upon x bar into 100. So this is the formula of your standard deviation. This is the formula of your standard deviation. Now, next is properties of standard deviation. Properties of standard deviation. So the first property for standard deviation is same like your range. Do you remember one thing? I have explained range of x is equals to mod b range of y. We have even solved the question. So similar to that, in mean deviation, in quartile deviation, I've already told you standard, whether it might be range, quartile, standard, or your mean deviation. The solving is going to be same. So over here, standard deviation of y is equals to mod b standard deviation of x. Standard deviation of y is equals to mod b standard deviation of x. This is your first property. Property number 2 is for any two values, standard deviation is half of range. Standard deviation is what? Standard deviation is half of range. So if there is only two values given, if there is largest number and the smallest number is given to you, and from that two values means only two observations are given. And only if two observations are given, we can find what? We can find range from it. What we have to do is just divide it by half. Just divide it by half. If you divide it by half, we'll get what? Range. So half of range, standard deviation is half of range. Standard deviation is half of range. Okay. So I'll give you an example. Find standard deviation and coefficient of variance. Find coefficient of variance. Find what? Standard deviation and coefficient of variance. The data is 50, 80, 90, 20 and 60. So the data is given over here: 50, 80, 90, 20 and 60. Standard deviation, find standard deviation and coefficient of variance. Okay. So first, for finding standard deviation, I write the formula over here. What is the formula for standard deviation? Under root x minus x bars square upon n, and the variance is going to be standard deviation ka square. So first I'll need what? X minus x bar, and now we know how to find x minus x bar. So there's going to be a one column of x, 50, 80, 90, 20, 60. So this becomes 100 plus 90 plus 50 plus 60. This becomes 300. Eh, what I've done? Yeah. So summation of x is 300. Now I need x bar. X bar is 300 upon there are observations, 5 observations. It is 60. So mean is 60. Now x minus x bar is 60 minus 50 is minus 10. This is 20. This is 30. This is minus 40. This is 0. Now I need what? X minus x bars square. So minus 10's square is 100. 20's square is 400. 30's square is 900. 40's 1600. Yeah, and 0 is 0 over here. So 1600 plus 400 plus 100 plus 900. Summation of x minus x bars square is 3000. So now the formula for standard deviation. Let's solve. It is going to be 3000 upon n is 6. 3000 divided by 6 is 500 and its root is 20. How many observations? Okay, so sorry, there are 5 observations. So 3000 divided by 5 is 600 and the root is 24.49. 24.50. Okay, so 24.50 is your standard deviation. And the variance over here is its square, that is, I don't need variance, right? I need coefficient of variance. So coefficient of variance is standard deviation upon x bar into 100. That means 24.50 divided by x bar is 60 into 100. 24.50 divided by 60 into 100. It is 40.83. So my coefficient of variance is 40.83 and my standard deviation of variance is 24. So this is your standard deviation and coefficient of variance, one example. Don't worry, I'm going to solve more examples over here, but hopefully this is the simplest example that I could have taken for you so that you understand the concept. So we know the formula. It is, see, as I already mentioned in the lecture 1, that the chapter is totally what? The chapter is totally formula based. So if you learn the formulas, it is going to be very easy to tackle this form or tackle this chapter. And if you, as I said, if you would have studied with me and after the lecture is completed, I don't think there is going to be any kind of issue for you all, because it is formula based. If let the chapter get like completed, now we'll be solving some of the examples of standard deviation, and there's a last topic pending, relationship between quartile deviation, mean deviation, and standard deviation. After that, we'll be solving what? We'll be solving MCQs for the chapter standard dispersion, and then the chapter gets over here. What we'll do is we'll revise all the formulas, and what you can do is, Bachalog, you can make a formula book and note down all the formulas. Like in central tendency, there were two parts, right? One was your mathematical averages, other was your positional averages. In mathematical averages, there was AM, GM, and HM. In AM, there were formulas for raw data and group data. So there were three formulas over there. In GM, there were three formulas. In HM, there were three formulas. Not actually three, only two formulas. Because if you remember, for the group and ungroup, there was the same formula, right? So there were only six formulas in mathematical averages. In your positional averages, there were more quartile, decile, and percentile. So if you learn at one formula for medium, very easily going to solve question for quartile, because you have to just change the base, right? For median, the base is 2, for the quartiles, the base is 4, for decile, the base is 10, and for the percentile, the base is 100. And similarly, for the group data, you were supposed to find CF, then rank, then search the CF in your rank, and the respective X was your either medium, quartile, decile, or percentile. Same goes with your group series. There was only a formula, L plus rank minus CF upon F into 100. For same, all the four things. So your central tendency part gets over, because in mode there's nothing. The most occurring frequency is what? Your mode. The most repeated item is what? Your mode. Oh, there's only a last a formula for your grouped series, and the formula for group series is what? L plus Fm minus F1 upon 2 Fm minus F1 minus F2 into 100. That's done. The central tendency part gets over here. Then we started with what? Then we started with dispersion. In dispersion, what we decided to do? Two types of dispersions. Dispersions were absolute dispersion and relative dispersion. In absolute dispersion, we saw quartile deviation, range and coefficient of range. Range formula was L minus S upon, L minus S, the largest number minus smallest number. And for coefficient, the formula was L minus S upon L plus S into 100. Here, your your range and coefficient of range gets over. Then we studied quartile deviation. In quartile deviation, there were two deviations: interquartile, semiquartile. Interquartile, it was Q3 minus Q1. Semiquartile, Q3 minus Q1 upon 2. And coefficient was Q3 minus Q1 upon Q3 plus Q1 into 100. So these were your coefficient of range and coefficient of quartile deviation and quartile deviation. Then we studied mean deviation. Mean deviation, there were three parts: from mean, for median, and from mode. It was x minus x bar upon n, x minus median upon n, summation of x minus mode upon n. For group, it was summation of f, x minus x bar upon n, x minus median upon n, summation of f, summation of x minus mode upon n. For coefficient, it was mean deviation about mean into 100 upon mean, mean deviation about median into 100 upon median, mean deviation about mode into 100 upon mode. That's all. The mean deviation also gets over. Then we studied standard deviation. Standard deviation, a formula was under root x minus x bar square upon n. As simple as that. If you take square of standard deviation, it becomes variance. For coefficient of variance, there is standard deviation upon x bar into 100. That's what your coefficient of variance is. So I just, how much time it is taking to revise all the formulas? Hardly 4 minutes, 3 to 4 minutes. Hardly 3 to 4 minutes. Are the formulas easy? Yes, the formulas are totally easy. If you learn the formulas like this, if you keep it revising cumulatively like this is going to be easily, you're going to score, you're going to get, the chapter is going to be for 4 to 6 marks. So the 6 to 8 marks. So you're easily going to score 6 to 8 marks in this chapter. Easily. There's not a big deal. The chapter is very easy. But only the reason that students don't attempt this chapter is it is very lengthy. There are many formulas. But if you learn the formula, it is not a big deal. It is very easy to cope up with the chapter. Okay. So yes. So let's go ahead and study some relation between quartile deviation, mean deviation, and standard deviation. Like we studied the relation between mean, median, and mode. Relationship between quartile deviation, mean deviation, and standard deviation. If the observations are distinct, if the observations are distinct, distinct means different. If the observations are equal, right? If the observations are distinct, your standard deviation is going to be greater than mean deviation, it is going to be greater than quartile deviation. If the observations are equal, you find standard deviation or mean deviation or quartile deviation, they all three are going to be same. And now a very important formula, quartile deviation can be equal to mean deviation can be equal to standard deviation even in case of distinct object. If you multiply 6 quartile deviation into 5 mean deviation is equals to 4 standard deviation. So even if the objects are distant, if you multiply the quartile deviation by 6, mean deviation by 5 and standard deviation by 4, they can be equal. They can be what? Equal. They can be what? They can be equal. So yeah, this is the formula that if you keep in mind. 6 quartile deviation is equal to 5 mean deviation is equals to 4 standard deviation. Now, standard deviation for first n natural number. There's a question on this point as well. There are high chances that a question can be asked. Find standard deviation for first n natural numbers. It might be first 10 natural numbers, for 20 natural numbers, for 50 natural numbers. The question is going to ask only. The question is going to be only this much. Standard deviation for first 10 natural numbers. No data, nothing. So there is a very easy formula for finding out. It is going to be under root n square minus 1 upon 12. Now, if 5 natural numbers standard deviation is asked, what am I going to do? 5 square minus 1 divided by 12 and then roots button. So what it becomes is 5 square 25 minus 1 divided by 12, it becomes 2 and it becomes 1.4142. For what? For your first 5 natural numbers. So you have to just add whatever natural numbers you want to find standard deviation, just you have to take the n's place is supposed to be substituted with it. So this is we'll solve an example. Standard deviation for first 25 natural numbers. It is going to become 25 square minus 1 upon 12. So sorry. So 25 square is 625 minus 1. 625 minus 1 divided by 12. It becomes 52 and under root 52 becomes 7.211. So this is your standard deviation for first 25 natural numbers. So the last point remaining over here we are going to see is combined standard deviation. Combined standard deviation. And the combined standard deviation formula is very easy again. standard deviation of 1 to very easy, very easy. Okay. N1 into standard deviation of 1's square plus D1's square plus N2 into standard deviation of 2's square plus D2's square upon N1 plus N2. So this is your formula for combined standard deviation. Now let's see what is this D1. We know N. We know standard deviation of 1. We know standard deviation of 2. We know N2. We don't know what is D1. So here D1 becomes x1 bar minus combined mean. So mean of 1 minus combined mean is going to give you what? D1. D2, x2 minus combined mean. So the D1 and D2 becomes what? We have to minus it from the combined mean. When we minus mean of 1 from combined mean, I get D1. When I minus mean of 2 from combined mean, I get D2. So this is going to be your combined standard deviations formula. So over here we have completed with our all concepts of dispersion as well. We have completed central tendency with its MCQs. We have completed dispersion without its MCQs. Yes, MCQs are yet to be solved, but all the concepts, everything with examples, we have completed your dispersion part. In the next lecture, we're going to see MCQs of dispersion. In the next lecture, we're going to see what? MCQs of the dispersions. So hopefully, all the students, if they're not going to watch the lecture instantly, I would suggest you one thing. Rather than jumping to the MCQ part, I would suggest go through the formulas first. Understand and learn the formulas first. If you have not made any MCQ book, please create an MCQ book. Write down create a formula book. I'm so sorry, my bad. Not MCQ book, create a formula book. Write down all the formulas in that book, learn the formulas, and then only jump to the MCQs lecture. So the next lecture is going to be the dispersions MCQs. And with that, we'll then complete the dispersion part. Yes, and if there's a student who is watching the lecture till the end and you are new to the channel, but I would suggest you to subscribe to the channel, because Akash Agarwal classes is going to bring you many lectures which are totally going to be conducted in English. And apart from that, there's a WhatsApp community which has been created. The link is in the description available. What you can do is you can join the WhatsApp community by clicking on the link given in the description, so that you get the latest updates and all the stuff, all the latest videos, link on time, which are going to be uploaded on that WhatsApp community. Yes, so see you all in the next lecture. We'll be completing the MCQs in the next lecture. Bye bye, keep studying.